Okay, for today we're doing lesson 5.2. And lesson 5.2, we're looking at linear factors and zeros. Now, and with this one, with the zeros part, we're going to kind of build up because in the next few lessons coming up, sometimes they're going to talk about zeros, sometimes they're going to talk about solutions, sometimes they're going to talk about x-intercepts, sometimes they're going to talk about roots. So all those words are kind of interchangeable. So when you see the word zeros, you could also think that that's roots. The word that we see a lot of times is your solutions. And when we start graphing some of these things, and we'll do a short little graph of these today, those are your x-intercepts. I think the word they're going to use mostly in section 2 is going to be zeros. But just so we kind of build up to things we're going to do. And when you see zeros, that's the same thing as a solution. That's your answers. When you start graphing, that's the same thing as an x-intercept. Sometimes if we're doing square roots on these answers, that's what they would call the roots for this part. So it's linear factors and zeros, but realize we've got some other words we can call it besides the zero. It's a solution. It's an answer. Think about it that way. Okay, and the big thing you've got in the first part is not necessarily the zeros part, but it's more the linear factors. Here's one thing we've got to look for when doing linear factors. You always want to look for a greatest common factor first. Okay, and then once we got the greatest common factor out of the way first, we're going to do, like we've been doing the last couple of tests, you're going to have to factor things, because that's why it's the linear factors. So if you didn't get a chance to get all the wrinkles out of factoring the first test, maybe didn't get them all in the second test, now you've got a third test where you get one more chance to do some more factoring. So it's still going to be there. Don't let all the things we've talked about go away. Okay, so first thing we're going to do is we're going to look at a couple of examples where we're going to just work on writing things out in factored form. Maybe it's a little different look of some things that we've seen, but just some things that will pop up as you're going through the homework, because you'll still have the standard factoring like we've had in things in the past. This one's going to look a little different, so we're going to show you a couple of different options of what you might see. Okay, let's go with x to the third minus x squared minus 12x. Okay, and with this thing up here, we're looking for greatest common factors first. And in this section, if you haven't got used to doing that yet, go ahead and do that in this section, and even the next sections when we start doing more of this. Always look for greatest common factor first. So what do these things have in common? All got an x, right? Number-wise, there's no numbers, but you got an x. So let's take an x out of all these. If you take an x out of x to the third, it leaves you with 2x's, or x squared. If you've got x squared, take one of them out, leaves you with just 1. Take the x out of the 12x, that's going to leave you with just the 12. And hopefully, if you take the x out of the front here, the inside part of the parentheses should look pretty familiar, right? So what are the factors of negative 12, where the sum is going to equal our middle term, which in this case will be a negative 1. Well, it's got to be some form of 3 and 4, right? 1 and 12, we'll get it. 2 and 6, so it's got to be 3 and 4, and that's a matter of the signs. Since the b term is negative, that sign goes on the bigger number. There you go. And to get the other side, just divide these two numbers. Negative 12 divided by negative 4. Negative divided by negative is a positive. There you go. So we've got the x on the outside, and we've got an x plus 3 and an x minus 4. So if they ask you to write in factored form, that's what you're looking for. Let's do one more factoring, and then we'll kind of walk that into the zeros part, where we're going to start finding the zeros. So let's do x to the third minus 36x. And again, first these, sometimes it's numbers. In this case, what do they both have? Both have an x, right? So let's take the x out of both of these. So I'll leave you with an x squared, and take the x out of 36x, just leave you with a 36. And for those two numbers on the inside of the parentheses, what are those two numbers? Perfect squares, right? Because x squared would be x times x, 36 would be 6 times 6. So as long as it's a difference of two perfect squares, that's when we can do our shortcut. And we can make this one x times x, and to get 36, we do 6 times 6. And since it's negative 36, one's going to be positive and one's going to be negative. Oh, going back to vocabulary terms here. What do we call it if you had the same factored expression where the signs were different in the middle? What was the name? Started with con. There we go. Thank you, Sarah. Conjugates. Okay, so if you get the same, so when you have the perfect square terms and you square root them, you get the conjugate, because one's going to be x plus 6, the other one's going to be x minus 6. Sarah, you go.
No way.
This way. Okay, now here's where they're going to start changing things just a little bit. Besides asking you just to find the factored form part, they're going to take that same problem and now they're going to ask you to solve. So you'll have x to the third minus 36x. Now, that's what we've said in the past. Here's where they're going to change the wording on it just a little bit, but it's still going to be the same thing. Instead of saying solve from here on out, for this section, they're going to ask you to find the zeros. That's the exact same thing as saying to solve it. So they're just saying it different because we're going to kind of put this on the graph in a little bit so you can see graph-wise what this would look like on a graph. So normally we've said solve in the past. For this section, they say find the zeros. It's still the same thing. Tell me what x equals when you get through this part. Okay, now the good part is we know if we factor this up here, it's going to be the exact same thing. We would factor this off as x times x plus 6 and x minus 6. So just taking the answer we had here, pull this thing down to get it in factored form. Once you've got the parentheses, just take each part and set it equal to 0. So we've got x equals 0, x plus 6 equals 0, and then x minus 6 equals 0. Okay, this one's good because there's nothing you can do with that one, so that's one answer. This one we can subtract 6 from both sides to get x equals negative 6. And for this one, we'll add 6 to both sides, so then we get a positive 6. Okay, and there's our 3 solutions. So the first few problems in the homework, you're just going to have to factor, not really solve anything, just find the factors. And then once you've got everything factored out, then they're going to start saying, now, tell me what the solutions are, or find the zeros. So whether they say solve or find the zeros, it's the exact same thing. And it's what we talked about a little earlier. If you start with x to the third power, there's your 1, 2, 3 solutions. So whatever your highest power, the degree of the term, if we go back to yesterday, whatever the degree is, that's how many solutions you should have when you go through this thing. And sometimes, again, it may be that the same answer repeats, so that you have the same answer twice, but it still technically counts as different answers there. Okay, so once you've got your zeros, you've got your solutions. The next thing they're going to ask you to do, and this is something that it's a new term. So far, we kind of really haven't done anything new. This was stuff you had done in algebra before, done the factoring. Here's something we're going to add in a new term. They talk about the multiplicity. And this is not to kind of borrow from the movie. Y'all remember the movie Megamind?
Yeah.
When he lived in Metro City, but he called it Metrocity. Same thing. This is not multiplicity. This is multiplicity. So, make sure you got the pronunciation good there. Put the emphasis on the right syllable, right? Don't put the emphasis on the wrong syllable. Emphasis. Yes, exactly. Okay, so here's what the multiplicity is. With a multiplicity, all that you're looking for is really pretty simple. Multiplicity is the power or the exponent, whatever you want to call it there, of each set of parentheses in factored form. Now, the thing with the multiplicity is they kind of introduce it in section 2. There's a little bit more you can dig into it to get a lot more things from the multiplicity, but they save that for pre-cal. So if you're going into pre-cal, they'll dig into the multiplicity and exactly what it means then. In Algebra 2, we'll just kind of introduce it and say, here's what it is. And then when you go to pre-cal, then they say, all right, well, here's what you can do with the multiplicity to help you graph these things and make the graph a little bit easier. We just kind of introduce it so you kind of at least have seen it, know what it's talking about, so that when you get to pre-cal, you can dig into it a little bit more. Okay, so for what we're going to do for the first example is we're going to do this where we're going to solve it and state the multiplicity, but we're going to have it so it's already pre-factored, so the solving is a little bit faster. So we're going to solve and state the multiplicity of each zero. So I'll give you one easy one of these, and then we'll do one that's a little bit tougher, so you can see the two options you'll get when you're going through the homework here. So let's start with x minus 2 times x plus 1 squared times x minus 4 to the third equals 0. So one's already pre-factored where you've got the parentheses, everything's set up, and then once we've got the setup with parentheses, here's where we're going to do two things. We're going to solve it first, and then once we've got it solved, then we're going to go back and tell you what the multiplicity is. And the solving, if it's pre-factored, should be pretty simple. Because to solve, you're going to take x minus 2 and just set it equal to 0. For that one, we'll add 2 to both sides. So x is 2. So there's one solution. We've got x plus 1 squared, so we'll take the x plus 1, set that equal to 0. Subtract 1 from both sides, and we've got x equals negative 1. And same thing with the x minus 4. We'll take the x minus 4 equal to 0. And for that one, we'll add 4 to both sides. So we've got x equals 4. Okay, so there's the solving part. And for the multiplicity, all you have to do, and we'll do it in red so it kind of stands out in a different color here. That after you solve each part, that basically in the homework they're going to give you a spot for x equals 2, and then beside x equals 2 they're going to tell you, all right, now what is the multiplicity of the solution x equals 2? So what you're going to do is, once you've got it in parentheses back here, you're going to go back and tell me what power was on the x minus 2. Now, there's not one there, correct, but how many x minus 2's are up there? Technically there's 1, right? So your multiplicity in that case would be 1. So as long as there's something there, there's one of those. For the x plus 1, it was squared. So the multiplicity of negative 1 would be 2. And then the multiplicity of x equals 4 would be 3.
That's it?
That's it. That's all it is. Now, and that's as far as they go with multiplicity. For this one, they say, all right, just tell me what the multiplicity is. For pre-cal, they dig into it and say, all right, here's what that means when you get 1, 2, or 3. This is the things you can do from this thing. And it ties into the graphs. But we won't talk about for that part because, again, that's something I say for pre-cal. Okay, and then the last thing with this one is to get the degree. Of whatever expressions you've got here, if that's an equation. You just add your multiplicities together. So if we were solving this equation with everything that's here, this solution had a multiplicity of 1, this one was 2, this one was 3. So the overall degree of this equation is we would add the 1 plus 2 plus 3. So if they ask you for the degree of this equation, the degree would be 6. Okay, so that's where they tie that in with finding out the degree, what we did yesterday. So all you do is just take your multiplicities and add them up. Okay, and does everybody remember what maximum and minimum means when we're graphing these? And again, you don't have to graph these, but max means it's a... Alright, and when it means you're going to have a high point then, right? So if we were doing that when we had negative with that part, but maximum was a high point, minimum is a low point. So they kind of go back and talk about that a little bit here and mention that, but everybody remembers what max and min are, so I don't think we have anything with that one. Okay, an example 2. Here's one where it's not in factored form. And this will be a good one to kind of watch because it's a little different setup than a lot of things we've done the last few days. So let's go x to the 5th plus 4x to the 3rd equals 5x to the 4th and minus 2x to the 3rd. Okay, and same part as the other part here. We're going to they ask us to solve it and state the multiplicity. And again, when you're solving these, they want you to solve by factoring, and to do that, we've got to get this thing equal to 0. So I would say first thing is, since we've already got x to the 3rd over here, let's add this 2x to the 3rd over here to combine with that 4x to the 3rd. So we've got x to the 5th plus 6x to the 3rd equals 5x to the 4th. And so the terms are going to be in standard form or descending order. When we move the 5x to the 4th over here to the left-hand side, since this is x to the 5th, let's put it right behind the x to the 5th. Okay, so when we factor, it's got to equal 0. So by moving these two terms over, we finally got it equal to 0. Now, if you're saying, hey, we didn't talk about x to the 5th. We didn't talk about how to factor that one. We didn't. So what are we going to look for? Greatest common factor, right? Got to find out what they had in common. So if you've got x to the 5th, x to the 4th, and x to the 3rd, you take out the smallest power of x's, so we're going to take out x to the 3rd. And then tell me what we've got left over. If you had 5 and you take out 3, it's going to leave you with x2. We've got the minus 5. If you had 4 and you took out 3 of the x's, it's going to leave you with 1x. We've got the 6. When you take out all 3 x's, then they're gone. So it'll leave us with that. So now if you just ignore the x to the 3rd for just a minute, that's the things that we can factor here. So we're looking for the factors of positive 6, where the sum is going to be negative 5. Okay, now don't get try not to get in a hurry on these because sometimes people would go, oh, it's got to be 1 and 6 because they're going to do 6 minus 1 and get 5. Or I'm going to do 1 minus 6 and get negative 5. That's true, but you could also do 2 and 3 and get 5, right? Because you could add 2 and 3 and get 5. You could subtract 6 and 1 and get 5. So this is where the signs are really important. So if this is a negative 5, bigger number has to be negative. And if we divide a positive and a negative, that means the other number has to be a negative. So they both have to be negative, so that means it's going to have to be 2 and 3. Okay, so now it's in factored form, so now we're just going to take each parentheses and equal to 0. And technically you could put that x to the third in parentheses, if you want to think about it that way. So we've got x to the third equals 0, x minus 2 equals 0, and x minus 3 equals 0. Okay, and if it's just x by itself, doesn't matter what the power is, what's the only number you can multiply over and over and over and over and still get 0? It's got to be 0, right? So no matter what that x to the power is, that one's x equals 0. This one will add 2 to both sides, and that one will add 3 to both sides. Okay, so there's our solutions. And then the one other thing they're going to ask us is, all right, now that we've got our solutions, what's the multiplicity going to be? So in factored form, for x equals 0, in the parentheses form that was here, this one was x to the third power, so for x equals 0, the multiplicity would be 3. For x equals 2, that was our parentheses here. There's not any power here, so again, that's still just understood to be the 1. And same thing for the x equals 3, that's understood 1. Okay, now for the one question that's on the homework, where you're going to ask to graph these. This is where they would have you come back, name the solutions, we got the solutions, name the multiplicity, we got that. This is where they're going to ask you to graph. And to graph these, here's the one thing that you're going to look for. Again, it's in multiple choice form, so you don't have to worry too much about this one. You're going to have to put a with your solutions, you're going to put a dot at those 3 numbers on the x-axis, because we got one at x equals 0, which is here, one at x equals 2, which is here, and one at x equals 3, which is here. Okay, here's the only other thing you're going to need besides those 3 numbers if you've got 3 solutions here. You need to know, with that highest power, what that x to the 5th is going to do. And that's where we're going to go back to the chart that we had yesterday. That if it was x to an odd power, and that number was positive, so back to what we did yesterday, that's x to an odd power, so that means we're over here in this column, and since that's positive, we're back to here, so we need the left side to go down and the right side to go up. So you take the leftmost point that you have now, and it's going to go down. You take the rightmost point that you have, and it's got to go up. And there will only be one graph, multiple choice wise, that has the right end from this going up and the left end from here going down. And it'll fill in the gaps and do something like that for that part. But you're not really, and what we're focusing on now is we're not really focused about what's happening in the middle, because that's what we'll dig into. We're more focused about what's happening on the end, so we can at least get the basic shape of the graph. So that's where we tie in that end behavior we talked about yesterday, is that once you've got your solutions, you take the rightmost solution that tells you what the graph is doing, you take the leftmost solution that tells you what the graph is going to do. And then the last thing for today is we're going to start working a problem backwards. Is we're going to write an equation given the solutions. Again, instead of saying here's the solutions, they might say here's the zeros that we have. Okay, and you could almost break this down where it's really only 2 steps to do. And let me give you an example, and we'll give you the directions on one half, and we'll show the work on the other side. So let's say we have 2 solutions. We've got x equals 2 and we've got x equals negative 3. Okay, first thing you're going to do, and this is almost like Jeopardy, where they ask you, here's the answers, tell me what the question is. This one's kind of the same thing. You've got the answers. We know the answers are 2 and negative 3. Now they're going to say, all right, what was the equation we started with? So we're going to have to do this thing backwards. So to kind of go backwards on this thing, the first thing you're going to do is you're going to rewrite the equation so you have x either plus or minus some number equals 0. But that's the key thing, is you've got to rewrite it so you have x equals 0. So for x equals 2 and x equals negative 3, now we've got to make so this right side is 0. So to do that, for this one, you would just add 3 to make that 0. And whatever you do to the right side equation, you've got to do the same thing to the left side equation. So that one's going to be x plus 3 equals 0. This one's a positive 2, so to get rid of the positive 2, you're going to subtract 2 on both sides. So that one we've got x minus 2 equals 0. Okay, for step 2, and we'll make it so it's a 2-step, and because it's really, if you separate it out, it'd be a very short step 2. Step 2 is you're going to put parentheses around each expression, because where we had solutions up here, well, now we've got expressions. We've got x plus 2s and x minus 3s. So we're going to put parentheses around each expression and multiply together. And when we're talking about multiplying in this case, that means we're going to do the full method. So once we've got the x minus 2 equals 0 and the x plus 3 equals 0 on this one, we're going to take those two things, put parentheses around the x minus 2 and the x plus 3, and that's the part we're going to fold together. Now, because they're still equal to 0, we're going to put 1 equals 0 at the end, but really we're focusing on doing this part of doing the full method here. Okay, so doing the full method, we've got x times x for x squared. X times 3 for 3x. On the bottom, we've got negative 2 times x and negative 2 times 3. And with the full method, when we do those, every single time, for the most part, those middle two terms should combine together. So we've got x squared. If we do 3 minus 2, that's 1. But again, we don't have to put the 1 because it's just 1x there. Minus 6 equals 0. And again, we had 2 solutions, so we should have had x squared to be our degree, because again, that's telling us every how many solutions you have, that's what you should start off with. Now sometimes again they repeat, but if they give us 2 solutions, we're only looking for x squared as our highest power term. Okay, so 2 solutions, not too bad. Let me show you one where you have 3 solutions. A little bit longer because you have to do the full method twice. And you'll get one of those. So we'll need to see it so you can have a feel for what you're doing with it. Alright, last problem of the day. Let's go with x equals 1/2. Let's go with -1 and +3. Same direction as before, we're going to take these solutions we have and use that to write an equation. Okay, so very first thing is we're going to take those solutions we have and make it so they're equal to 0, so we're going to move them to the other side. Since that's a positive 1/2, we're going to subtract 1/2 on both sides. This one we would add 1 to both sides. And for this one we would subtract 3 from both sides. X minus 1/2 times x plus 1 times x minus 3. And when you look at that and you go, ooh, I don't like the fractions. Okay, here's how we're going to get rid of the fractions. Just like before when we were factoring and getting to the answers and doing parts on this one, we have a fraction on this one. Go ahead and do bottoms up to undo that fraction. So all those same rules that we were doing before, they're still in play here. So where you've got x minus 1/2, if we don't like that 1/2, just pull the 2 up in front of x. Let's make it 2x minus 1. And that way, no fractions, we're all whole numbers, and it makes the multiplying out a lot easier when you go through this. Okay, so now that we've got the fractions going, let's do the full method. And we just take the first 2 in line and multiply those together. So we've got 2x times x, and then 2x times 1, so that's going to be 2x squared plus 2x. And we've got -1 times x, and then -1 times 1, so it's a -1x minus 1. And we're doing the full method there, so we'll just kind of block that one off. And inside that one, again, you can always, almost every single time, combine the middle two terms. So that makes it 2x squared plus 1x, or just x, minus 1. And the x minus 3 that was here, not doing anything with it yet, so it's just kind of hanging along on the end of it. Okay. Once you've got the full method done with the first 2, you've got this combined down to the 1 term. Now you've got to do the full method again, which means now instead of doing it just to 2 numbers, you take this x and you got to multiply it by all 3 numbers. So that's 2x to the 3rd. X times x would be x squared. And -1 times x would be -1x. Okay, then we're going to multiply by -3. Now here's a small little shortcut you can do to make this thing look a lot cleaner and a lot neater than just putting these 3 numbers behind it. If they didn't show you this when you were doing Algebra 1, here's what you do if you get a longer expression you've got to do the full method with. Instead of writing everything at the end, when you take the -3 and multiply it times 2, that's going to be -6x squared. put it underneath the like term there. So take the negative 6x squared and put it underneath the x squared term that's here. We do negative 3 times x, that's negative 3x, put it underneath the x term. And we do negative 3 times negative 1, that's a positive 3. There's no just numbers, no constant terms. So just put that on the end. And now you can just add it together. And that way everything's lined up. You don't have to move anything around. Just start adding and subtracting up and down. 2x to the third. You've got basically a 1 minus 6, so that would make that a negative 5. X squared. Negative 1 minus 3 is negative 4 with the x and then the plus 3. And they'll tell you to write it as an equation, so they should have an equal to 0 there somewhere.